Hi, in this video, I am going to share a constant current load which I inspired by some other videos on YouTube. I used a PCPSU case and fan. This load will withstand to 10 ampere, 24 volts and 160 watts. In fact, it can handle 15 ampere, but digital voltamperemeter has 10 ampere shunt, so I limit it to 10 ampere. It will have input for probes, input for wires, a digital voltamperemeter, 2 potentiometers as coarse and fine adjustment, heat-sensitive fan and overheating warning LED. Not the best, but a little bigger. To isolate my circuit and heatsink from the case, I used a plastic sheet. Plastic sheet is ½ centimeters above case by spaces for isolation. Drilled some holes to screw it to case. There are some applications to calculate how much power heatsink can dissipate. Some of them are basic, but this is more complicated and it gives detailed explanations. The freeware version has some limitations, such as you cannot specify height and length of heatsink, but default dimensions luckily gets close to my heatsink dimensions. I chose fan-cooled heatsink, right dimensions of heatsink, right CFM of fan as 35 for 12 cm fan. Power sources are MOSFETs, which are 2 IRFP 250 MOSFETs in my project, and placed them on heatsink. First I tried 100 watts per each, but the inner temperature of MOSFETs have reached 166 centigrade, where these MOSFETs can handle 175 centigrade. But to be safe I tried 75, 80, 85, 90 watts and decided at 80 watts per each. At this point MOSFET inner temperature will be 139 centigrade, which 25% below of max temperature, and the coolest part of heatsink will be nearly 56 centigrade, where I can place a NTC. MOSFETs are to 247 case, big enough to dissipate heat. I spread some thermal paste to facilitate heat much easily. I used 8 ampere wires for connection, where I cut from PSU connections so 2 MOSFET can drain 16 ampere theatrically. I cut the plastic sheet and make holes at the bottom of the case where MOSFETs are, to get out heated air easily. Drilled some extra holes for ventilation. I cut an L-shaped board for circuit. Draw front panel template and cut a piece of acrylic for aesthetics. I painted case to black for an original appearance. This will be the main circuit. I used two IRFP 250 MOSFETs and two LM 358 op-amps. There is no need for resistors or capacitors between MOSFETs and op-amps. There are two 0.1 ohm resistors connected to ground. To adjust ampere I used 150K and 110K potentiometers. Connection of potentiometers is shown for fine-tuning. Wiring of digital voltamperemeter is at the bottom. This is the source for op-amps. I need at least 0.5 volts to flow 5 ampere for each 0.1 resistors and MOSFETs, so used a voltage divider. I tried and find 0.56 volts is much close to drain 10 ampere from the device. There may be a voltage drop in some components, wires, connections, or my resistors are not exactly 0.1 ohm. I used a refrigerator NTC which I had. It's covered plastics which causes some delay when sensing, so I sanded plastic until I see the metal case. Refrigerator NTC specs are the same as ordinary NTCs. I decided 45 degree to run fan at max speed, tried with potentiometers to find the exact values for resistors. I used LM 317 MOSFET, so I lose nearly 1.5 volts at output, which is acceptable for me. I also added a 3mm LED as overheating warning. LED will begin to glow when fan runs at nearly 10 volts. I tried with potentiometers to find resistor values. This project was lingering on my bench nearly 2 months and at last it's finished. I read many forums that most of the people who tried this circuit are suffered from circuit drains not lower than 100 to 200 milliamperes. At the start of this project I tried OP07 op-amp and circuit draws at least 540 milliamperes. So I changed back to LM358 op-amp. Now it draws at least 20 to 30 milliamperes. Although I have two potentiometers as coarse and fine, it's sensitive to adjust low amperes. Better use 10-turn potentiometer. I tried with an old LiPo battery to find maximum ampere. It drains 9.8 ampere with ease. Then I tried if it really draws constant current or not. Result is success. Thanks for watching.